Hello kids, welcome back to my channel Hi with Himani. We are doing a second chapter, whole numbers. We have already covered what whole numbers are, what natural numbers are, number line and properties of whole number. I will be sharing the links of all the topics below in the description. We've already covered knowing our numbers. That will also be shared in the description box. The links will be shared. So today we'll do the last two topics of this chapter. The first is the two identities, additive identity and the multiplicative identity. Second, we'll do the patterns of whole numbers. Both are simple, so let's do it. First is the additive identity. Additive identity is a number which, when added to a whole number, the value remains the same. What does it mean? It is saying that if, suppose A is a whole number. What is this? A is a whole number. So, some number is added to it. The number is added to it in such a way that the value of this whole number remains the same. This number which was added is known as additive identity. So, I'm sure you can guess that which number can come here? The number which when added to another number, the value of the number doesn't change. So, yes, I am sure that you must have got it right, that this number is nothing else but 0. 0 added to any number will not make the value of the number changed, right? So like if there is this number 101 and 0 is added to it, still the value remains the same. Or we can take different numbers, 563. So if 0 is added to it, still the value is 563. So this 0 over here, is the additive identity of the number. So now, multiplicative identity. Multiplicative identity is a number which when multiplied to a number, the value of that whole number remains the same. So here also it is quite logical to know what is that number which will be the multiplicative identity of all the whole numbers. Can you guess? Just see, if A is a whole number, which number needs to be multiplied to it that its value remains the same? Can you guess? Yes, it is 1. We know that if number 1 is multiplied to any of the whole numbers, the value of that whole number remains the same. So here it is, 562 into 1 is 562. Simple. And this rule applies to all. So now, we have learned the additive identity and the multiplicative identity. Additive identity is a number which when added to a number, the value of that whole number remains the same. So that number, additive identity is 0. Multiplicative identity on other hand is number 1, which when multiplied to any whole number, the value of that whole number remains the same. So these two identities are simple and clear, quite easy. इसमें ज़्यादा कुछ सोचना करना था ही नहीं, तो easy. Now, very interesting topic. That is the last part in your NCERT books. That is the patterns of whole numbers. What is told here is that the numbers are represented into elementary shapes using dots. Elementary shapes are made out of these dots. So what are those shapes, those elementary shapes which are used as patterns of whole numbers? First is the line, second is rectangle, third is the square, and fourth is the triangle. So let's do one by one. The first one is the line. All whole numbers could be represented by a line. What does it mean? Like, for example, number 2. Number 2 could be represented by like this, like a line. Number 3, like this. So this is the representation of whole numbers as line. Now, whole numbers as rectangles. All even numbers could be represented as rectangles. Like this. And 6. So we know that square is also one form of rectangle. So 4 and 6, these are represented as rectangles. Now we'll talk about squares. All numbers which are squares of any number could be represented as squares. Like 2 2s are 4. So 4 is a square number. This could be represented as square. 1, 2, 3 and 4, as I have shown you earlier. Similarly, 9 is also a square number. This could also be represented as square. So simple, we know what is a square. Square is nothing but A into A is square. So A number of dots here and A number of dots here will make a square. So all square numbers could be represented as a square. Square, square. Simple. Nothing much to learn. The last one is the triangle. How a triangle has to be formed. So how a triangle will be formed? Like this. 1, so number 3 is represented by a triangle. Now if I have to move further, if I have to make a bigger triangle, so how many numbers do I require? This is 6. Or in other words, I can say this was 1 plus 2. This was already 3, and what I've added? 3 plus 3. See, look carefully the pattern which the triangle is following. Then, since this is already 6, this much is 6. So now if I have to make another bigger triangle, it will be 6 plus 4. This will be equal to, this was equal to 3, this was equal to 6, and this is equal to 10 dots. Now what about a bigger triangle than this one? This much was 10. Now if I have to make even a bigger triangle, I need 5 more dots here. So this much, this triangle we have already discussed that this triangle has how many dots in it? It has 10 dots in it. So 10 plus 5, that is 15. So this is the pattern which the triangular number follows. it's very important because at times it comes, so I'm again repeating it. This time I'm not making it with dots, just the pattern, if you remember. The first one, I'll just represent this first one only. Yeah? This first one was like this. 1 plus 2. It was equal to 3. Then the another one was 3 plus 3. That was equal to 6. We already had 6, right? So another bigger triangle will be 6 plus, how many dots we have added earlier? 3. This time we'll add 4. And we had this number 10. For next pattern, we will use this number over here, 10. And this time, the number which will be added will be a number 1 bigger than the previous number which we have added. So that makes it 15. Another number which will make triangle will be 15 plus, tell me, 6. That is 21. Another number will be 21 plus 7. That will be 28. Similarly, this pattern will continue for triangle. So in exams, at times it might ask, there is this question which may come, that amongst all these following numbers, which number can be formed as a triangle? Like this question over here. What do you think will be the answer? The answer is 21. Another question over here. This question is asking, which of the following numbers could not be represented as a triangle? Amongst this, you again have to select that which number will not be a triangle. This you will only be able to do once you have understood the pattern of how the numbers are being formed in a triangle. So it's simple. We have to start from 3, then 3, then 3 plus 3, 6, then 6 plus 4, 10, then 10 plus 5, 15, then 15 plus 6, 21, and 21 plus 7, 28, 28 plus 8, then 36, 36 plus 9, 45, 45 plus 10, 55, and so on. I know you don't have to mug up. You'll be able to just figure it out then and there. The numbers which will come in your exams will be small, so no need to worry. So here are we have completed everything, right, of whole numbers. So we'll again meet in our next video. So thank you so much.